On this question, we want to determine the difference quotient, f of x plus h minus f of x over h. So this is what the difference quotient is. And we want to find that difference quotient for this function, f of x equals x squared minus 21x. So to calculate the difference quotient, I'm going to do it in stages. I'm going to start with this part right here, which is f of x plus h. And to calculate f of x plus h, we want to change every x in our function to x plus h. So if we do that, we would have x plus h squared minus 21 times x plus h. Now there's some simplification that we can do with this expression. I'm going to go ahead and do it now rather than waiting until later to do it. So x plus h squared means x plus h times x plus h. And then with the second term, we can use the distributive property and distribute the negative 21 to both of those terms. That's negative 21x minus 21h. For the x plus h times x plus h, we're going to multiply that out and get x squared plus xh plus xh plus h squared. And then I'm going to copy this minus 21x minus 21h down. I do have some like terms. xh and xh are like terms and can be combined. That's going to give me x squared plus 2xh plus h squared minus 21x minus 21h. So that's x plus h. So the next part of the formula for the difference quotient has you subtracting f of x. And f of x is the function that was given to you. F of x is this function here, x squared minus 21x. So if we want to calculate the whole numerator, we want to subtract, that's the difference part, difference in the name. We want to subtract f of x plus h minus f of x. So let's work that out. We have f of x plus h minus f of x. That's going to give us the whole numerator. We've already calculated f of x plus h, so I'm just going to copy that down. That's x squared plus 2xh plus h squared minus 21x minus 21h. Then I want to subtract, I'm going to put a minus here, I'm going to subtract f of x. Now this is really important. I want to subtract the whole function. So I need to put parentheses around f of x to make sure that this minus sign applies to the whole function. So I'm going to put parentheses and write down what we have here for f of x. That's x squared minus 21x. Then we'll distribute that negative. So I'm copying all this down at the beginning, no changes here. And using the distributive property, that becomes minus x squared plus 21x. And we want to simplify. We do have some like terms. We have an x squared and a minus x squared. Those are like terms, and when you combine them, they're going to zero each other out because they're opposites of each other. So those actually cancel out. And then we have another pair of like terms here, negative 21, it's not that one, sorry about that, negative 21x and positive 21x, those are like terms. They're also opposites, and when we add them together, they will zero out, so we cancel those terms out. And the terms that we have left are 2xh plus h squared minus 21h. So this is going to give us the numerator of our difference quotient. So finally, we want to calculate our whole difference quotient, which is f of x plus h minus f of x over h. And we have just calculated the whole numerator, so I'm going to write this in the numerator. 2xh plus h squared minus 21h. And we're going to divide that by h. We have 3 terms in the numerator. So what I'm going to do is I'm going to distribute my division into 3 fractions. That's 2xh over h plus h squared over h minus 21h over h. The h's cancel, and on this one we have h squared over h. So one of them cancels here, and that one cancels there. We're going to be left with 2x plus h minus 21. And this is our difference quotient for the function f of x equals x squared minus 21x. So the difference quotient came out to be 2x plus h minus 21. On this question, we have the graph of h of x shown in the picture, and we want to find the function values h of 5, h of 7, and h of 8. So this picture that we see on this grid is our function h of x. So that line is h of x. And we want to find h of 5. So with this notation, what we have to understand is that the value that's given inside the parentheses is a given value of x. And the notation h of 5 is another way of writing y. So as we look at these symbols, what we want to know is, what is y when x equals 5? So as we look at these symbols, this is the meaning that you should take away from those symbols. So we're going to use the graph to answer this question. We're going to look for an x value of 5. So looking on the x-axis, we've got an x-coordinate of 5. On my little circle, we have an x-coordinate of 5. We want to find that x-coordinate on the graph. So the point I'm highlighting now is an ordered pair that has an x-coordinate of 5. And if we go over here to y, we can see that the y-coordinate at that point would be -1. So we can label this point as 5, -1, and that tells me that h of 5 is the y-coordinate, which is -1. We'll do the same thing for the other ones. We have h of 7. So that 7 is the x-coordinate. We want to find the y-coordinate. So on our graph, here's where x is 7. And on the picture itself, on the line itself, we want to focus on this point because it has an x-coordinate of 7. You can see that the y-coordinate would be 3. So we'll label this point as 7, 3, and that means that h of 7 is 3. And then let's do h of 8. So we know from this notation that x is equal to 8. X is equal to 8 here. We can find that on the graph right here. This ordered pair has an x coordinate of 8. And if we go to the left, the y coordinate is 2. So h of 8 is 2. For this question, we want to determine whether the function is even, odd, or neither even nor odd. And we're given this picture here to determine whether it fits into one of those categories, even or odd, or the catch-all category of neither even nor odd. So what does it mean for a function to be even? An even function has a definition that we can find algebraically and a definition that we can find graphically. For the graphical definition, we know that even functions will have y-axis symmetry. And same thing with odd functions. It has an algebraic definition and a graphical definition. The function that is odd will have origin symmetry. So if we want to put this graph into the category of even or odd, we need to know what these types of symmetry mean. Now, when a function has y-axis symmetry, let me highlight the y-axis for you. The y-axis is this vertical axis here. When a graph has y-axis symmetry, what you'll find is that you have a mirror image on the left and the right of the y-axis. So if you can imagine that this picture is a piece of paper and you're going to fold the piece of paper along the y-axis, if you have y-axis symmetry, you would have both sides matching up. So you can see that that's happening on this picture. This piece of the graph, when folded, would match up with this piece of the graph. And this piece of the graph, when folded, would match up with this piece. So this is a graph that has y-axis symmetry. And so we would categorize this as an even function. Now you can't have a function that is both even and odd. So I know this is not going to be odd, but I think it's a good time to describe origin symmetry. So when a function has origin symmetry, let's start by marking where the origin is. The origin is where the x and y axis meet each other, cross each other. So the origin is the ordered pair 0, 0. And when a function has origin symmetry, what you would see in the picture is opposite quadrants with a mirror image. So this is quadrant 1. Quadrant 1 always starts in the upper right hand. And if this graph had origin symmetry, you would see a mirror image in the opposite quadrant. So right now I'm highlighting quadrant 3. So in those opposite quadrants, you can see that we do not have a mirror image. So you can see this piece of the graph here, and there's no mirror of that in the third quadrant. You can see this piece of the graph here, and there's no mirror of that in the third quadrant. You would also have a mirror image in quadrant 2, which I'm trying to highlight. In quadrant 2, this is quadrant 2, and then quadrant 4. So when you have origin symmetry, you would have a mirror image in those opposite quadrants. So let me give you a quick picture of something that has origin symmetry. So if you had a picture that looks something like this, and then you think about these opposite quadrants, this quadrant is a mirror of this quadrant, and this quadrant here is a mirror of this quadrant. So if the picture looks something like this, we would have origin symmetry, and we would label the function as odd. So as we said, this picture does have y-axis symmetry, and we would label this picture as an even function. Thank you for checking out my videos. Have a great day.